Evan McGee, and this talk is called Getting Your Asterisk in Gear, the Web Services Edition. And so what we're going to do is we're going to go through sort of the style that Ring Plus. So I work for Ring Plus. We are an MVNO, MVNE based out of the US. And what we do really is we're sort of a very innovative phone company. We offer service like Boost Mobile or T-Mobile or AT&T or anybody else like that. But we run our entire tech infrastructure ourselves out of a number of different data centers and on sort of the cloud level. So it lets us do a lot of just sort of very rapid innovation and a lot of sort of really interesting developments with phone service that most telcos can't do because they're using a lot of legacy vendor equipment and they have a lot of sort of built-in infrastructure. And so this talk is going to be sort of about how we go about doing that. Like how do we, and what tools do we use to make that innovation possible and rapid and kind of keep everything moving and kind of engage our customers. And the reason for all this is to create more business opportunities and to create sort of like a better ecosystem for developers to work in, both internally and for external developers via an API that we use, and also just to sort of just provide more value for everybody. And because, you know, telco service, no one really loves their phone company. If I had anyone, you know, raise your hand if you love your phone company, right? Exactly, zero. Nobody likes it. They pay their bill and they move on. And so we are trying to get away from that. And Ring Plus offers free phone service, which is why we do a lot of this stuff. But let's back it up for a second. Asterisk right now lives primarily in a bubble. And we all know this is the traditional Asterisk deployment, where maybe you're fronted with a couple of Camelios. They kind of forward to Asterisk. Maybe you have Asterisk in a sort of a DRBD, sort of CoroSync pacemaker situation. Maybe you're storing your files on NFS, and perhaps you're using some sort of shared database in the back end, right? This is pretty typical for most basic Asterisk deployments. And that's fine, right? You know, you can throw a couple different RTP engines in there, or RTP proxies to get this moving. And that's sort of very static. It works well for static IVRs, PBXs, things like that. But as your company grows, and hopefully they all are growing or will grow soon, you're going to start running into a lot of limitations and a lot of problems. And the issue is that how do you start scaling this in a way that makes sense, in a way that enables you to use it to increase your business and also to, you know, make your lives easier and frankly more interesting. Again, it's a stable, well-worn, it's sort of standalone. One of the traditional facets of an Asterisk installation like this is that it doesn't really need to interact with outside services at all, right? It kind of just hangs out by itself. Maybe it does a little bit of external querying, but traditionally kind of just has it all in the dial plan or in channel variables and kind of takes care of everything that way. Don't have to really worry about it otherwise. Well, you know, eventually you're going to find some other problems, right? You're going to run into issues. Maybe you want to bill for phone calls slightly differently. Okay, well, billing is a big thing, right? Billing suddenly becomes, well, you need to get information on accounts and the balances and stuff like that. You might need to get into fraud management, you know, particularly if you're doing some sort of, at least in the telco world that we live in, people, you know, abusing the phone system, making international calling, as everyone knows. Or maybe they're just sort of like leaving their wireless channel open for a long time, using that spec, you know, we need that to know these sort of things and sort of monitor them in real time. Again, call track analytics, and you use that for some big data analysis to actually see what your customers are doing. Perhaps you can see that, you know, like a bunch of people in New York are suddenly calling a bunch of people in Atlanta. Maybe there's a reason for that, who knows? Again, performance monitoring, you want to know how your systems are doing so they don't fall over if there's a big spike in traffic. Call quality analysis, same sort of thing, throw some Homer in there. Maybe it's more advanced failover if you have a data center somewhere. Let's say you're growing this up and you have a data center in New York and Hurricane Sandy hits and suddenly all of Manhattan's cut off, and that's something you never really thought was ever really going to happen. And I speak from personal experience on this. It's good to have a redundant data center somewhere else that the traffic can just go to that can use the exact same resources and has all the same account information, and the customer experience is negligible. They have no idea anything happened, whereas you watch them carry buckets of gasoline up to power the generators for your servers. And again, maybe you're also moving into the world of WebRTC or just anything else, right? You need to starting to get into multimodal interactions where maybe a call is coming in, has to perhaps get boosted up to video at some point or have an option to get boosted to video, or you just need to move it onto the web in some case. Maybe you need to record it or screen share it or any other, you know, multitude of reasons. Or you're inventing a new one and this is a service you want to offer. These are all things where that standalone Asterisk suddenly becomes like just a small piece of a much larger infrastructure. And they all have all these things up there, the billing, the fraud, everything else, usually are just very different domains, different specialities, and you got to combine them all, and it doesn't make sense to have them all sort of in one spot, like on one server right there, sort of all talking to each other. You have to spread these out. There's a lot of processing here and a lot of complexity. So, you know, this starts moving into sort of the real-time web, and what I wanted to say about this real quick is just that if you're dealing with asterisks and telephony, you've been dealing with the real-time web since the beginning. Like the real-time web is sort of the hot word now for like, PubSub and it's all push stuff and everything that's great. That is what RTP is, right? The real-time protocol. We've been dealing with that in this industry forever. So we are very well acquainted with what the real-time web is. And now web developers are finally catching up to what we know about the complexity of actually having to do things where latency is a problem, where actually, things need to happen immediately. Again, because this is the new paradigm, consumers expect sort of that instantaneous feedback on things. I mean, if you've been looking at even Reddit recently, they're putting out a beta feature on Reddit where the live comment, sort of live update, is no longer, like page refreshes are no longer allowed. Single page apps have to be, Ajax loaded and have everything just sort of show up instantaneously. They're running into the same problems that we used to run into, but on the web. It also means a lot of times that these systems have to talk to each other. There's a lot of talking going back and forth, right? Via WebSockets, via REST, whatever it has to be. There's a lot of communication happening here. And they all sort of need to feed into the same sort of real-time architecture. The other side of this is that you're getting a huge amount of information usually dumped in at once that has to be processed and parsed and gotten out into various different capacities as fast as you possibly can. And Asterisk, like I was saying, is real-time before real-time was real-time. It's big time now. So it's time for Asterisk, that initial installation, to kind of leave the bubble. It has to stand on its own 2 feet in the world of sort of web services and interconnected things. And it can do that. So this is sort of a sample of a small sort of snapshot of a piece of like the Ring Plus internal architecture, where over here on that side you have a lot of the sort of Asterisk clusters that sort of all live over there. And you have a bunch of different APIs that feed off of like a sort of a primary data stream. There's a lot of, these little boxes are going to load in weirdly. These are sort of little spun up instances that live on DigitalOcean we use a lot. We can kind of spin up as many as we need to for capacity's sake. But there's a bunch of stuff here, right? Ring Plus does a lot of ringback tone replacement. One thing is when you make an outbound phone call with our service, you hear music and news and advertisement, and that's how we subsidize your phone service. So we have a big section here that is RBT selection, where we have to do a lot of complicated logic based on who you are, what your calling patterns are, what radio stations you signed up to, like what you have clicked on before, to decide which RBT to play for you next. There's billing, there's fraud, some logging databases. There's a bunch of other stuff in here that's not listed, but one important thing is they all need to talk to each other all the time. And we could do that with sort of a traditional, REST style, everything talks to everything else, but it gets very complex fast. The billing system needs to talk to the database, also needs to talk to the RBT selection, because if you don't have enough money, it actually plays with different RBTs, suggesting that you top up more. These things are all sort of communicating all back and forth, and it can get just very messy if everything's talking that way. And there are simpler ways to do it now. Just hey man, that sounds pretty complex. And it can be, but it doesn't have to be. And the tools are coming out very rapidly to make this a simpler and simpler process. One of the things, now if you haven't played with it at all, is container-based orchestration. So if you want to choose Docker or Kubernetes, whatever you want to do, if you're comfortable with using virtual machines, I'm not trying to talk you away from them. I'm just saying that the containers and the ease of deployment when you create a static image of your application is well worth investigating and well worth looking into. If you haven't looked into how container deployment works, I would highly suggest getting out there and doing it. Docker is the one that we have sort of chosen internally. Just the straight up Docker engine and the Docker Swarm, they're lightweight, they're easy to move around, they just do single processes at a time. They should be sort of ephemeral little beings that kind of live and die. You can think of it, the classic example is if your VMs are cats and they're all names, they all have named, like Lucy and Timmy, the container should be more like cattle. They just have numbers, right? It's like, 3, 4, 5, and they can just be killed off and, well, unless you're vegan, don't worry about that. But they can be sort of taken away to pasture, new ones brought in. And the point is, they're just totally replaceable, and they should be exactly the same state of your application, be brought up and down, or scaled out as fast as you need. If you have a call spike or anything like that, suddenly you can just stand up 20 more Asterisk servers for 2 hours, and then just power them back down again. They do have a higher packing density than virtual machines because you're sharing a lot of the underlying libraries and systems. I mean, you can actually get more stuff onto a single server, which is great. If you're paying, again, for VM space in the cloud, you can actually get more onto each one. Docker networking is probably the one big thing I would caution everybody about, is that particularly in Docker, the networking is still sort of evolving. And they launched 1.12 in June, and they launch about a new point release every couple months now. And it does finally allow for, Docker had a limitation previously where it couldn't talk amongst multiple hosts. You can only do Docker on one host without a bunch of other complicated sort of whodittery. But they have fixed that. However, it doesn't really work all the time the way it should. They're actually starting to release point releases like 1.12.2 is the newest one coming out that fixes a lot of this stuff. But it does do some pretty great things. It does have a built-in sort of using the IPVS Linux router to automatically do load balancing across all the containers that are running inside of a swarm. That's nice. It means you can sort of, for a lot of cases, remove things like HA proxy. It takes out some of the complexity there. It makes it so you just expose a port 80 or port 443, and suddenly all of your TCP traffic goes amongst all the containers that are registered to receive that port across any host you want. So if you have a cluster of DigitalOcean, I'm going to use them as an example, in like Toronto and San Francisco and New York, you're running containers on all of them, then the inbound ingress port on any of them will communicate to any other one automatically using the router. So you can actually ingress information from at any point and have it distributed around, making it a much more fault-tolerant system. Like I said, it's still evolving. Documentation is always lagging behind because the point releases are so rapid, and they always invent something completely brand new in the new one. So if you look at any articles and they're more than about 2 months old, I really wouldn't worry about it. There's still some issues with service discovery, and there's just bugs. It has bugs, so you run into them. They're very responsive, and they fix them quickly, which is great, but they are there. So you run into a problem, make sure you note it and be like, it might not be something you're doing. It might actually be a problem with the infrastructure. And it's not a magic pill. It still requires a bunch of dev and ops and management and everything else, but it does let you do some pretty amazing things when it comes to being able to scale and replicate your architecture. In particular, if you have a lot of developers, it allows you to have that glorious magic holy grail of parity between production and development. Exactly what you're running in development, you just bundle it all up, you stick it in an image, that image is exactly what you deploy to production. So there is no difference. And if you've ever been bitten by that bug, you can understand like how irritating debugging developer versus production problems are. And it can solve that, and it is wonderful. Another thing too is like this is a good use case where we have a lot of call traffic on one of the virtual machines that's going through here, and using a lot of CPU, and on the weekends, nobody makes any phone calls. I don't know why, but people apparently, like everyone calls during the week. Everyone's working, on the weekends everyone's outside playing, and so we don't use nearly as much traffic. So guess what? We can turn off a bunch of virtual machines at that point and save money over the weekend. And it's so easy, it's one literal command, docker scale 10, and it will just gracefully shut down 10 containers or whatever it is, turn off those machines, and for 2 days, so that adds up over the course of a year. And this is the kind of metrics you can start pulling out, the kind of information, and using Docker, making it much, much easier to sort of, do this sort of fun scaling. Yay. Okay, another great thing. So I'm going to go into Kafka here real fast. Kafka is a pretty amazing piece of technology built by LinkedIn when they realized that they were getting just hammered with events. They have, as you can imagine, running a social network like that, they have an incredible real-time event stream, and they couldn't keep up with it. They were just, having problems with their database scaling, everything else. So, and they had an infrastructure kind of like this one I was talking about. Everything was talking to everything else, lots of just random, REST requests going around, or database queries, or trying to throw things into Hadoop, whatever. What they really wanted was some sort of central system that they could just push things into from all the different sources and pull things from, and it would just make it simpler. And that can't be something like a Postgres or a MySQL cluster, because those relational databases weren't built to do this kind of rapid data ingress and egress. They wanted low latency, they needed to be fast, and they needed replayability. They needed the ability for a client to attach at one point, another one, maybe one's reading way down the line and just getting started, and one is just like trying to keep up with the newest information. One is bulk loading, one is near instantaneous. So they invented Kafka. And all Kafka really is a distributed commit log. You can kind of think of it sort of as a Git log, but what you do is here's the stream, as they call it, and as things are added onto by producers, there can be many producers at once, all sort of writing to what's called a topic. And a topic is sort of anything. The stream is just a series of key value stores. So 11 is a key value, 12 is a key value, and all they are updates. It's like, if you think about it in database terms, it's like doing an insert, just sort of constantly inserting. If you have an update, the update is another key value store, right, that just kind of keeps adding on to the end of the commit log. At this point, Consumer Brian, as a developer, he's like, oh, well, I need to replay the stream from 13 or 14 all the way to the end to figure out what's changed. Consumer Alice is trying to do something totally different. Maybe Brian is working on anti-fraud stuff, and Consumer Alice is actually doing some sort of billing reconciliation. They can actually both come into the stream at any point they want, replay it from any point, and while the producers continue to write to the end of it. And they can actually keep reading through it till they get to the end. This whole thing, the stream is actually in Kafka, replicated across 3 different nodes as well. So it is sort of a high availability, fault-tolerant system built into Kafka, which runs on Zookeeper. Sort of, that's the whole ecosystem they use. And what makes this great is that it allows you to have many, many, many consumers and many, many producers all writing to the same thing. and it's built specifically to allow for massive writes and very quick sequential reads without having to do any kind of querying. Again, you can't do any kind of SQL stuff on this. It's just for getting information in and out. And like I was saying, you can have multiple, it has multiple copies in the back end. So what could you use this for in Asterisk as an example, right? Well, Asterisk has lots of events that happen all the freaking time, right? You have CELs pumping out events all the time. You have CDRs you got to process. Well, you could easily take those and basically tail them, just tail the master CDR. In fact, here's the command you can even use to do it. And here's the GitHub repo of the guy who built this little tail Kafka Go routine. It's like maybe 75 lines, maybe 50. It's very small. It just tails the CDR, throws it into a topic in Kafka, and that topic can then be consumed by whatever other system needs that information. If your CDRs need to go into billing, they need to go into fraud, they need to go into whatever you need it to do, they can be consumed by an API doing that sort of thing. They just attach to the topic, they have a notification when a new item comes in, they just start reading forward, and you're good to go. And it makes it so those independent systems can work by themselves, doing their own thing. You can break those apart. They may even be parts of the same monolithic application. Let's say you're writing your application in Rails or Django or whatever you want. It doesn't matter. Stand up different instances of it. Maybe one instance only does billing, and one instance only does fraud. They can be the same application base, just with different priority domains of what they're trying to process. So we go back to here. So that's why Asterisk over here kind of just talks to the Kafka stream over there, and everything else reads off of it. Right? Postgres reads off of it. And this, I'm not saying that these things only attach to the stream. The API can also hit the Postgres if it needs to, and the RPT selection can hit a bunch of other stuff. But the point is that all the information, at least in this particular instance, is dumped into the stream from anything that is producing it. Right? So the database doesn't produce much information. It just simply consumes it, ingests it, and does queries. But Asterisk produces quite a lot. Now we're going to go into Adhearsion for a minute. If you were over listening to Luca Pradavera's talk, he was covering Adhearsion and some of the amazing things you can do with it. Adhearsion allows us to do things and scale things on the business logic side of the actual phone calls themselves. If you haven't heard about it, I suggest looking at it. It's a third-party call control framework. It's written in Ruby, works with both Asterisk and FreeSwitch, hooks into the AMI and AGI interfaces. It allows to do TTS. One of the best things about it, though, is that it really gives you access to the big Ruby ecosystem from right inside your sort of Asterisk call flow. You can actually just start using the leverage and the built-in power of that community and how much time they spent creating gems and solving processes, everything from converting money to doing kind of very complex API transactions with third-party systems. You can use those without having to build them yourself. And if you want to know more, you should have gone to Luca's talk about 45 minutes ago, or contact him at Mojo Lingo. They specialize in Adhearsion, but allows for some pretty rapid and amazing application development. And if I could say one thing, it'd be that Adhearsion could be something that helps us deprecate sort of dial plan. If you don't like writing dial plan, you could write only Ruby, and your life would be a lot more fun, I think. So there are some problems, right? There's some issues here. Adhearsion runs along sort of one-to-one with the Asterisk in this case. Ruby itself is locked via the global interpreter locked, only one CPU. That's kind of an issue. You can get around it by using JRuby. It's not what we do. But you can do it, and a lot of people use JRuby and get along really well with it. Let's say your call volume is exceeding a particular node of either Asterisk or Adhearsion, right? They both have independent concerns for CPU. I call it Pokemon Go syndrome, if only because as running a telecom company, we saw a big spike in data usage when that happened. And we were like, why is everyone using data? And I was like, oh, everyone's catching them all. So the same thing, you just got to scale the nodes. As we talked about earlier with Docker, super duper simple. It took, you can automate that, or it takes maybe 15 seconds to run it. And if you have them sort of one-to-one, you're like, great, you stand up a new virtual machine, you've already profiled what it takes, you throw the container on there, or you already have some virtual machines waiting around, and off you go. They automatically load themselves into Docker. Docker automatically does the load balancing. If you have Chameleon in front of it, you can also just update the Chameleon dispatcher rules, and off you go. I just want to throw this up here real quick as an example of what you can actually do with Adhearsion very, very quickly. Because I did mention in my talk abstract that I was going to say how you can manage your phone calls from your Twitter feed. Well, this is a good example. Here's a little Ruby code you can use that just requires the Twitter gem and another little HTTP party, which is just a wrapper to make posting requests easier. And this is it. This entire thing right here, you set your Twitter secret keys, you basically walk down into it, you are collecting the tweets from someone's timeline, you strip out any kind of nasty HTTP stuff just so you don't have to read it out loud. This is just a simple curl request that goes to nuances ndev, throw in some app keys here, writes it out to a file, and plays that file. And right there, you're reading back all of the Twitter feed from somebody inside the phone call. And this is literally, you could just almost, I think, copy and paste this with the right keys into an Adhearsion app, and it would read back anybody's Twitter feed you want. Now, if you had an API call here to get someone's Twitter handle out of your database or wherever you have it, then suddenly you could read them back anything you want from Twitter. Or down here, the next thing is like, look at this. You could look at their timeline and say, do any of their tweets include hashtag Astricon? Well, guess what? I don't want to be contacted at any point when I'm at Astricon, so it just hangs up the call. I don't want anyone to reach me while I'm here. I'm busy. But you can do things with the Twitter gem also. You can actually do place check-ins with Twitter and that kind of stuff. And you can actually say, if I check into Astricon, maybe there is a person here with me that needs to take all my calls while I'm here because I'm really that important. And it can actually literally forward all my calls to that person based off your Twitter stream. This is simply an example that I want to throw up here using Twitter because it's a fun one. But imagine this sort of blown out to anything, right? You can have any source of information to dump in here. And using Adhearsion makes it just incredibly easy to start grabbing that information out of other pieces. You can do this with Stasis as well. I'm not saying you can't. There aren't other ways to do this. If you want to use Stasis and use JavaScript, be my guest. The issue is just to get your head into the idea that, oh, I'm going to be consuming information from so many different other endpoints that can actually inform what I'm doing now inside a call. There's also a bunch of asset management options here. And asset management comes down to basically where you're going to store. As you're scaling these things up, occasionally people leave voicemails. In the case of Adhearsion, it needs access to actually play the files, the sound files. There's a lot of different, for Docker in particular, volume storage plugins. And what these do is allow you to make your storage backed by some other sort of larger entity. Because Docker inherently does sort of more local storage, and the problem with that is that if you store like a voicemail file on one container, it's not going to replicate across because that's not what it does. That file exists on that one container. So you back it with things like S3 or Azure or Gluster. And these allow for data persistence across multiple containers as you scale, right? As they scale up, you're loading up your Azure file storage or your Gluster FS. You throw those in there. Suddenly, one change propagates to everything, right? You can do this with config management as well. You throw your config into one of these systems, and suddenly all the configs that you had, if you update them across one, you scale down your nodes, you scale them back up again. All the new ones pick up the new config changes automatically, and off you go. You're off to the races. So data persistence is still an evolving topic in container orchestration, but there's a number of different solutions on there. And so my personal preference for these is to use cloud-backed storage just because it's also redundant and it saves you from, again, Sandy, Hurricane Sid. So another good example is, so we just, Ring Plus just released sort of, the FCC has come down and said basically that they have an FCC task force that is making anti-robocalling and stopping robocalls and spammers a very, very high priority for telecoms. And it's a problem that's being worked on. At the very low level, there's some initiatives like STIR, which would actually include a cryptographic key in the initial sort of offer of a phone call, which could then verify that the person actually, it's a verified phone number. But right now, that's years down the line. It's an IETF spec. They're working on that. So right now, we have more limited options. But we can still do a lot with anti-fraud and anti-robocalling. And so what we do is you can take ingress. The FCC actually has an API that gives you robocall numbers and reported to them and spam numbers. You can ingest those into the data stream. We can also use things like, at least Ring Plus, we use about 100 million calls worth of data to do some data analysis on those calls to look at a bunch of different metrics of, what's happening in those calls. Who's calling, rapidity, are they answered, how long do they talk for. We also have a personal blacklist feature. We can blacklist individuals. We look at that, have numbers been blacklisted across multiple different people in the system, and a lot of other things. And the machine learning we built in there sort of aggregates all this information and writes it out to the data stream and says, okay, here are the numbers that are blacklisted. It also writes out to sort of a Redis instance, and that Redis instance is what is consumed by Asterisk and Adhearsion because we want it to be fast. When you're calling in, we don't want it to have to sit there and think forever while it's trying to do some complicated math or even go to the database and pull it out. It has to be as quick as we can. So as soon as the call hits, we look up, is this number that's calling me something that is blocked by the Ring Plus Universal Blacklist? If it is, then shut it down. And if it's not, then go off and get the account information and the billing information and load everything else up. And so these are the kind of services also that once we have the ability to get that data into a very easily consumable place, from inception to completion of that sort of anti-robocalling was maybe 2 days of developer effort and just like 1 work week from when we started it to when it was done. And it is now blocking tens of thousands of calls a day from spammers to people. And it's working pretty great. And we're pretty excited about how fast this is using the idea that we can now communicate between all the different pieces very, very quickly. And it doesn't impact, we spun up a couple new servers to handle the load, and off they went, and they just do their own thing. And of course, Asterisk then rewrites that information back to the data stream as well, right, using using the tail mechanism. So again, I'm Evan McGee. I work for Ring Plus. I hope you guys have learned something. This is sort of a high-level overview of how these web services can all work together to sort of present a more coherent, more advanced system than maybe you've traditionally used. Maybe you use a lot of these tools already. If so, keep doing it. Thank you so much.